When we talk with customers, they tell us, we need a more flexible, cost-effective method of building core business processes that allows us to quickly react to competitive threats and market opportunities. They also ask us for advice about how to determine the most appropriate platform for deploying those applications. And they ask, how are other IT shops organized to develop and deploy modern applications? Hi, I'm Paul DiMarzio, a System Z software strategist with the IBM Corporation. In this program, you will learn the differences between services-oriented architecture, or SOA, and earlier programming models. And you will learn the significance of those differences. Because the design of SOA applications is platform agnostic, you will learn how to determine the most appropriate platform for hosting SOA applications. You'll also learn where to start to quickly capture benefits of SOA techniques and lessons learned by early adopters of SOA. And finally, you will learn how to organize teams to design and implement SOA applications. In addition to myself, there are several other presenters in this program. One is Irving Ladowski-Berger, Vice President, Technical Strategy and Innovation for IBM. Another is Jim Stallings, General Manager of IBM System Z Division. And a third is Kevin Kelly, a Senior IT Architecture and Strategy Consultant for Kemar Solutions Incorporated. I think you will find their observations and analysis quite interesting. If you are viewing this program via the internet or on CD or DVD, you will have access to the program transcript, a glossary of terms, and links to related websites, key documents, recommended books and articles, and relevant vendor information. Our first key issue is, what are the differences between SOA and earlier programming models? What is the significance of those differences? Let's start by looking at some baseline definitions so we're all using the same terminology. First of all, what is a service? A service is a repeatable business task that directly correlates to a business function. It's not a technical function like sending a file to a printer. Instead, think about what your company does on a day-to-day basis and break those business processes up into repeatable business tasks or components. Second, what is service orientation? Building on our definition of a service, service orientation is a way of integrating your business as a set of linked services that produce specific outcomes. Again, we're not talking about technology, we're talking about a thought process and a specific business design. And what is SOA? It is simply the IT architectural style that supports the service orientation thought process, the technology approach that makes business services and service orientation a reality. And finally, what are composite applications? These applications are the actual running services that have been assembled and linked together to support what your business does. SOA makes building and adjusting composite applications fast and easy. Let's take these definitions and ideas and put them to work in a real-world business example. For our case study, I've chosen the retail banking industry and the retail payments process. I like to use this example because banks are early adopters of SOA and because I have a great deal of experience with these early adopters. Also, banks exhibit many instances of internal and external connectivity and workflow between multiple organizational entities, making them good models for other industries with complex supply chains and complex applications, such as retail distribution. If retail payments is designed as a set of linked services, we have the ability to make changes. For example, let's give the customer greater control over a business task with a browser interface. In this case, the approval process. Next, we might identify services that would be useful to business processes within other parts of the bank. Within the business service area of payment operations and throughout this business process, there are common services required across payment types, such as verifying adherence to requirements from the Office of Foreign Assets Control, exception handling for instances that require a more specialist review, and risk management policy adherence. These can be implemented as shared business services, reusable services that other processes can use. Now, our bank begins to identify commodity types of services, ones that are not core to the differentiating qualities of the bank. In this case, processing specific types of payments could be offloaded to partner banks. And these suppliers can change depending on costs and quality of services provided. In other words, the originating bank outsources to a second bank, a supplier bank, allowing the originating bank to focus on the things that make them stand out. In a similar fashion, the supplier bank may outsource part of the service as well. For example, check processing may be handled more efficiently by a third party. At this point, we have four entities involved in this business process: the customer, the originating bank, the supplier bank, and the outsourcer. We may find more opportunities to move out other services. Images of documents captured in branches and/or checks need to be stored and retrieved efficiently. This is a business service that may also be outsourced. And we have the ability to quickly and easily change or fine-tune services to reflect adjustments in the business process. For instance, real-world experience may dictate ways to optimize the clearing process that is a core competency of the bank, making that process stand out with customers. So the business benefits of SOA begin to take shape. They include flexibility, or the ability to make changes to improve business processing; creativity, by buying services, building new ones quickly, or reusing existing services that can be linked together in a business process; economy, by reusing services across multiple business processes; efficiency, by offloading services that don't make the organization stand out, like check processing or imaging, to businesses that handle those services for other banks without having a disruptive effect on the process overall. So how do we generalize these ideas? Well, in the course of many engagements, we've discerned the need to take a life cycle approach to implementing SOA. The beginning of the approach is the model phase, where business requirements are gathered and designs are simulated to verify the fidelity of the approach with what the business needs. Once composed and tested, which is done in the assemble phase, they are combined with new and existing services to form composite applications. That's what we've covered up to now. Later on, we'll study two other phases of the SOA life cycle. And of course, underpinning all life cycle phases is the concept of governance that provides guidance and oversight for the SOA initiative. Now, there's one important idea that I'd like to share with you here. The life cycle approach does not require you to start at the beginning and methodically work through to the end. You can jump in wherever it makes sense, which is exactly what we're going to discuss when we focus on how to quickly capture benefits of SOA techniques.
Let me tell you how I think of service-oriented architecture. At heart, it is an architecture that enables us to decompose software into modules and then pull it back together. The reason that is so important is that as a result of having service-oriented architectures and all the standards around it, instead of having monolithic, static, inflexible software, we can have far more flexible, dynamic software that allows the business to change their applications and the software that implements it as they need to do that.
Well, the combination of System Z and SOA is extremely powerful for customers. Many of our customers have deployed millions of lines of code. They've got large databases. They've consolidated hundreds of workloads on the platform. And what they really want to be able to do now is implement a set of services in a very, very efficient way. So they want to reuse the implementation of these workloads and code on this system. But one thing that's very, very important is that these customers in these environments, especially our largest customers, they can't afford any downtime. So as you deploy this new services-oriented architecture, you also can't afford any security breaches. And the most important thing is they've got to be available to their clients, to their businesses, 24 hours a day. So the mainframe has these attributes of zero downtime, always available, always on, scalable, and secure. And it gets married up with this new, very elegant and efficient services-oriented architecture. These services now that can get extended and made available to the entire enterprise. So it's a great combination of value in this architecture for many, many of our customers.
Continuing with our first key issue, let's look more closely at the differences between SOA and earlier programming models. In basic terms, SOA is about integration. Integration of services at the business layer, as we saw in the retail banking application, and integration of components at the technology layer. Integration is not a new concept. There have been many different technologies introduced in the past that focused on integration. So what's different now to make integration easier and more effective than past solutions? First, widespread adoption of standards. The technology industry is getting together and focusing on common standards for web services, for connectivity, that allow all participants to deliver the same well-defined interfaces that will allow this service orientation to become a reality. Second, a manic focus on a loosely bound, dynamically linked style of connectivity. This is a big shift from the past. The old client-server approach meant you had to know exactly where you were going and possibly who was calling you before invoking a service using a tightly bound call-return interface. The result was a very fragile environment that could not be easily changed. SOA enables a loosely bound, dynamic link type of connectivity that's better suited to a service-oriented style of business. Third, reuse. When interfaces are standard and services are shareable, business can drive down operating expenses. Looking technologically, where are we in terms of making this happen? In the early generations of connectivity, applications were hardwired, establishing direct connectivity from point A to point B and usually using a proprietary protocol. In this case, the person building the application had to worry about everything, not just the business behavior of the application, but also how to achieve connectivity, how to mediate differences in message formats, to start and stop transactions, to validate security, and so on. All of this, what we often call plumbing, was the responsibility of the application programmer. It helped create the mess we're in today. The first step in the evolution to SOA was the advent of message queuing. Message queuing provided different ways for making interactions happen. It allowed us to adopt a loosely coupled approach where we could start to think asynchronously. It represents the embedding of responsibility in the middleware. Connectivity logic is abstracted from the application. A developer no longer worries about getting from point A to point B. Let the middleware do it. I do still have to know about point B and the fact that I want to get there, and I still have to know the message format. I do have to configure all endpoints defined for every requester, but the physical act of getting things from A to B was handled by message queuing middleware. However, the topology is still fragile. I still have to update all points in the network when a new service is added. Everyone has to know about the change. The next step on the evolutionary ladder was the introduction of message brokering. Here, we take message queuing to the next logical step. We added more smarts into the middleware that relieved the programmer of the need to define all possible endpoint connections. Unlike with the previous generation of middleware, there is no need to update all of the points when a new service is added. Now we have a hub and spoke architecture, where the message broker is the hub and all the endpoints are the spokes. To get a message from A to B, give it to the message broker and it figures out how to get it there. No need to pre-wire. Message brokering also introduced the intelligence to mediate different message formats. If my method is in one format and my request to a service is in a different format, the message broker can handle that for me. This greatly simplified and reduced requirements for the application developer. Developers don't need to know as much about the partners with whom they will be receiving messages. SOA is the next iteration, the next turn of the crank for connectivity technology. It takes message queuing and message brokering to the next level by introducing what we're calling an enterprise service bus. The bus is like a broker, but it provides that last bit of smarts, moving the last bit of communication responsibility out of the application and into the middleware. Now the application is pure business logic, defining business behavior. An enterprise service bus handles the connections, message mediation, transformation, transactions, security. All the plumbing logic is embedded in the middleware. So in many ways, the technology of SOA is based on concepts and technologies that are already very familiar to customers. Some customers tell me that they have been doing this for 20 years, and they have. Many have taken message queuing and message brokering products and created their own enterprise service bus infrastructure. What's new is that we're now able to provide these functions through formalized mechanisms and middleware that can be purchased to do the work for you. We're trying to make it even simpler. These ideas set up the final phases of the SOA lifecycle. In the deploy phase, assets are deployed into a secure and integrated environment, taking advantage of specialized services that provide support for integrating people, processes, and information. Once deployed, customers can manage and monitor their composite applications and underlying resources from both an IT and a business perspective. Information gathered during the manage phase is used to gain real-time insights into business processes, enabling better business decisions and feeding information back into the life cycle for continuous process improvement. Our second key issue is, if the design of SOA applications is platform agnostic, how do we determine the most appropriate platform for hosting SOA applications? One unfortunate outcome of the growing interest level and understanding of SOA is that the platform agnostic view of the development cycle has led to a similar platform agnostic view of the production platform. I frequently hear customers say, let's find the cheapest place to run this middleware, because every service in SOA has the potential to run on any box. In practice, however, it's the production environment where most of the money can be saved or wasted. As we did with the communications section, let's quickly review the evolution of master computing platforms and workloads. One of the most knowledgeable folks that I know on this topic is Kevin Kelly, a senior IT architect and strategy consultant for KeyMar Solutions Incorporated. Listen to what Kevin has to say.
The workload is less predictable than it used to be. I can recall working on an online banking system in the 1970s and early 1980s. We knew exactly what to expect in terms of year-over-year workload increase, and we were bang on the money with our capacity predictions. Then work became more interactive. We started to see the first manifestations of customer-driven workloads, and things changed. Because of the unpredictability of some of the work types and the increasingly dynamic nature of the demands being placed on the environment, there was a need for a sophisticated workload management capability. Managing heterogeneous workloads is not just a little more difficult than managing homogeneous ones, it's a lot more difficult and radically different.
Unpredictability is perhaps the greatest challenge surrounding SOA, and specifically SOA deployment. Let's look more closely at our deployment options. Mainframes were designed to run multiple heterogeneous workloads simultaneously according to an established set of business priorities. Mainframes know how to handle unpredictability. Because of its design, the mainframe historically has offered a number of advantages in key areas such as adding and shifting capacity based on business priority, identifying and fixing problems within the infrastructure, managing security and compliance, applying changes and upgrades to infrastructure and applications, implementing and managing integration between applications, and adding new applications without disruption to those already in operation. Distributed servers have grown in popularity because these low-cost, entry-level boxes, networked with modern communications gear and protocols, simplified the process of putting business applications at locations where the work was performed. The qualities that make the mainframe most effective were traded off for the simplicity of acquiring and quickly deploying new applications and services for individual projects or business units. Since distributed servers are only designed to do one thing at a time, unlike the mainframe, an SOA deployment to distributed servers will necessitate a farm of servers with resources dedicated to each individual application or task. The net result is that the most effective solutions for individual projects may result in an overly complex and costly infrastructure for the enterprise as a whole. This is a well understood problem, and many vendors, including IBM, are busy building software to try and address the issue. The most common technique is to try and virtualize an infrastructure of server farms. This is helpful, but virtualization technology today can only typically deal with a single type of resource, such as a set of WebSphere application servers, and it cannot extend to other resources that may be part of the composite application. Furthermore, virtualizing a complex infrastructure only addresses part of the problem because it does not consider the need to handle complex transactions across multiple resource types and roll back distributed transactions when problems occur, effectively monitor end-to-end transactions in complex configurations, or meet stringent security and regulatory requirements. So the fundamental question is this: is there value in physically co-locating new SOA applications and middleware with the System Z resources that are part of composite solutions? Should we consolidate onto a centralized platform like System Z, or push a lot of our new infrastructure out to distributed servers and have a multi-tiered approach? Does deployment really matter? I'll share with you the experience of one of our customers to illustrate a larger point. In a proof of concept project, this customer deployed their business logic and all business processes on a distributed platform, which in turn made calls to data logic on the mainframe. The thought was that running that platform-agnostic business logic on a distributed tier would be less expensive in production than the mainframe. However, the average CPU time consumed by each transaction was 11.7 milliseconds, and the average amount of data transferred per transaction was 54.4 kilobytes. This translated to an extremely heavy and unexpected load on the mainframe. Rather than saving money by running the business logic on a cheaper platform, the overall cost of the solution was far greater than expected. Now, it's important to note that this was not a problem with the mainframe. It was a problem with the deployment pattern. When the business logic portion of the application was moved from the distributed platform to the mainframe, the resource consumption was startlingly and dramatically different. The average CPU time for the transaction dropped down to 2.6 milliseconds, and the average amount of data transferred per transaction was a mere 0.5 kilobytes. The effect of refactoring the business logic to be co-resident with ZOS data meant that the average CPU time per transaction was reduced by over 77%, and the number of bytes of data transferred per transaction was reduced by 99%. No application coding changes were required. The business logic was simply moved to the mainframe to be close to the data that it was accessing. These types of results clearly go a long way towards explaining the unpredictability of deploying SOA applications and show how a consolidated mainframe approach towards SOA deployment can minimize the negative effects of such unpredictability. I've worked with many customers who do benchmarks on proof of concept systems to determine whether one solution is cheaper than another. While such IT best practices may have been valid for older client-server type deployments, they tend to fall apart in the SOA world. When deploying SOA workloads according to current IT principles and procedures, things don't always work out the way you planned. For example, the outcome of one customer's analysis showed that the memory required to handle the workload in a distributed environment was significantly greater than imagined. Memory alone made up nearly 3/4 of the cost of each server in the configuration. You might say that this doesn't matter because memory is not very expensive on distributed platforms. But when you have to configure each and every server in a massively parallel server farm with the necessary amount of memory, it may add up to a fairly significant piece of change. And the reason why so much memory is often required? A distributed topology incurs network latency. And every time you delay a transaction, even by a little bit, you're forcing the server to hold locks in memory longer. Multiply this delay across millions of transactions, and you're requiring a lot more memory than you would if there were no latency at all. There are many other examples I could share if we had more time. The net of it is that the deployment decisions are not platform agnostic. They have a major impact on the results that you are going to get. When SOA services are composites of new business logic and existing System Z resources, the most effective results will usually be gained by co-locating all elements of the service onto the mainframe. Our next key issue is, where do we start to quickly capture the benefits of SOA? As we've seen, SOA is a flexible method for defining business applications that are composed of linked business services which are mapped onto an equally flexible IT platform. But the problem is that most customer application architectures look this way: a mess of connections, a whole slew of different pieces, some overlapping, some redundant, some that nobody knows what they do anymore. Enterprise customers have all sorts of assets on the floor, on average 400 to 1,000 systems among our top customers. They've got the mainframe that continues to be absolutely critical to their business, needs to be brought forward into this new type of world. They've got distributed platforms that were often brought in for specific types of applications, but which usually have links back to the core system. A ton of ad hoc integration exists among these systems. There are numerous external connections to partners and suppliers. It's become a real nightmare for most customers to maintain what's going on in their business. This is a tough starting point for a lot of folks. Today's typical application architecture is an extremely complex starting point, so getting to a flexible IT is going to take time and patience. What does this mean for running SOA applications on System Z? First, it's not necessary, and certainly not desirable, to ditch those assets and start from scratch. Customers have invested trillions of dollars in these assets, core assets that have been running their businesses for years and are just as vital to them in the SOA world. An incremental approach to SOA deployment is recommended. Start by enabling and extending existing CICS COBOL and IMS applications and related data stores to allow IT shops to quickly build the foundation for a services-oriented architecture. Once the core assets are enabled, customers will have a significant inventory of services that can be quickly assembled using the SOA Foundation tools. Remember I said that you can jump into the SOA lifecycle where it makes sense? For System Z customers, it may make sense to jump in at the deployment phase. SOA enables reuse of resources. It's not a rip and replace approach. Rather, it's incremental technology. All existing resources that sit on System Z today are candidates for SOA. CICS transactions, IMS transactions, DB2 databases, vSAM files, anything that sits on System Z can be reused in an SOA infrastructure. The WebSphere brand allows us to unlock these core assets by delivering the tooling and the runtime. We're good at helping you discover and compose services from existing assets. In our experience, composing and reusing existing assets is the best way to get quick return on SOA investments.
The best way to explain the benefits of SOA is by analogy to explain the benefits that the Internet and World Wide Web brought to the world of IT. And even though the Internet has only been in wide use in the commercial world in, I would say, 10 years, it's made dramatic difference. And perhaps the biggest difference of all is that as a result of having a very standards-based, flexible infrastructure, businesses are able to connect all their pieces in a very dynamic way. They can reach out to all their customers, to all their employees, to all their business partners. They can integrate them all together in ways that would have been unimaginable just a few short years ago. We want the same flexibility to come to the world of software and to the world of applications. And it's not there today. In fact, the best way to realize that it's not there today is look at how cumbersome most ERP implementations are, enterprise resource planning. And most clients will tell you that they have to do it because it's critical to run their businesses and their various functions like finance, HR, and so on. But they feel it almost pours cement on their business. That's not good, especially in today's fast-changing marketplace. SOA, in my mind, is the way to take that cement away. And just like we did with the Internet, with networks and content 10 years ago, now do the same thing with all the components of a business.
Well, SOA and System Z are a very powerful combination. And it's primarily because SOA is a business thought, and it's about the business. How do I take this architecture, this services-oriented architecture, these services, these capabilities I have now, and extend them globally throughout the enterprise, every department, every organization, and support not only my customers, but my supply chain downstream. Now, there's some things that are very important as customers deploy this. They can never go down. They can never have security breaches. If their business doubles overnight or in a short period of time, they got to be able to scale this new capability as the business scales. Well, the mainframe, quite frankly, comes to their business SOA ready. It's got the highest mean time between failure. I mean, the system literally has got mean time between failure that's close to 30 years or greater. We have customers that have never been down in a decade. This is the most secure platform. It's got EAL level 5 certification by government organizations worldwide. So this marriage of the mainframe and this new architecture of SOA allows companies to run their business in a secure, predictable, but also a very manageable and comfortable way. So we think it's extremely important as companies consider their business and consider the value of SOA that they also consider the attributes of the mainframe, which are all embedded in security, availability, and scalability.
Our final key issue is how to organize teams to design and implement SOA applications. According to Forrester Research, the conventional way of organizing, staffing, and managing the IT function may work against leveraging SOA. The traditional IT organization is structured around building and supporting vertically integrated, siloed applications. IT roles, responsibilities, skills, and budgets are focused on discrete projects addressing specific business activities. Projects are scoped and delivered with little recognition of common business functions, missing an enterprise perspective and the opportunity for optimal solutions. These organizations will not be able to identify and capitalize on opportunities that SOA provides. IT must switch its emphasis from supporting departments and applications to playing a facilitative role in improving business operations. The IT organizational structure itself should change to deliver service-oriented IT. So what to do about the Forrester analysis and the types of new management challenges that arise when embracing SOA? In our experience, most IT functions are organized as follows. Here is our recommendation. First, adopt an enterprise view that avoids suboptimizing the enterprise by optimizing projects, the trap that many people fall into today. Based on our experience, the enterprise architect should have that responsibility. The enterprise architect will work to protect the existing information assets, work with others to specify the appropriate deployment platform, and document how to build new assets that can be linked with existing assets in an SOA-compliant manner. Next, focus on reuse. To support this focus, we propose that project management be changed to project and enterprise management. We suggest a new role in that group, the reuse office. The key operating relationships for the reuse office are with the following groups. Application design and development, because they create the business process artifacts. Application maintenance, because they will identify the code that can be componentized for reuse. Data, information, and knowledge management, because they know where and how to get data and to locate data as close as possible to SOA business transactions. Integration and installation, because this team is responsible for the enterprise service bus. Operations, because they will determine which platforms to deploy SOA applications on. And finally, enterprise architecture, because they will be the ones who ensure conformance to standards and tools used in the organization. Thank you for taking the time to learn about SOA and learn the role of the mainframe as an SOA platform. In this program, you have learned the differences between service-oriented architecture, or SOA, and earlier programming models. And you have also learned the significance of those differences, how to determine the most appropriate platform for hosting SOA applications, where to start to quickly capture benefits of SOA techniques, the lessons of early adopters of SOA, and how to organize teams to design and implement SOA applications. Just a reminder that if you are viewing this program via the internet or on CD or DVD, you will have access to the program resources, such as a program transcript, a glossary of terms, links to related websites, key documents, recommended articles, and relevant vendor information. I'm Paul DiMarzio. Thank you for watching this program.